In this question, we are told that there is a certain height and a ball is dropped. And when it's up here, it has a gravitational potential energy of 10 joules. It falls to the ground. It bounces upward. And when it comes back up, it has a gravitational potential energy of 0.7 joules. Well, what we know now, if we want to put in the kinetic energy here, because we've got potential and gravity interchanging, is that at the bottom, we have a kinetic energy equal to 10 joules at the instant before it hits the ground. So 10 joules gravitational potential converts to 10 joules of kinetic energy. Something happens here during the impact, and the kinetic energy that it has is converted into gravitational potential energy. There's no reason for any of it to be lost there. So this kinetic energy is 7 joules. So what happened to the missing 3 joules? Well, the missing 3 joules, that energy is lost during that impact. The ball compresses, and that creates internal friction, and some of that kinetic energy is converted to thermal energy. So what was the mechanical energy of the ball floor system the instant it left the floor? That is right here. And so that's why it's choice C, 7 joules. If it had been 0 joules, then it wouldn't have gone anywhere. It would have stayed there. If it had been 3 joules, well, it would only go up to a height equivalent to 3 joules. And saying it's 10 joules means it's somewhere between this location and this location it lost 3 joules. I have no idea what that would be or why, and why wouldn't we have lost that on the downside as well. So that's why it's choice C.